An oil of viscosity 5 poise is used for lubrication between a shaft and sleeve. The diameter of the shaft is 0.5 meters and it rotates at 200 rpm. So here rpm means revolution per minute. It's a speed unit. And calculate the power lost in oil for a sleeve length of 100 mm. The thickness of oil film is 1.0 mm. So at last we have to find power lost in oil. Okay, na? So anyhow, first of all, let us draw the diagram based on the given data. So here, an oil of viscosity 5 poise is used for lubrication between a shaft and sleeve. So there is a shaft and sleeve. This is sleeve and a sleeve. So this is sleeve and this is shaft. So rotating element is called shaft. Rotating machine element is called shaft. So this space filled with oil. The clearance between shaft and sleeve is filled with oil. This shaft ki sleeve ki madhyalo manam em chesam oil anedi place chesam. We filled with oil. So for what purpose? Lubrication purpose. Okay na? So to reduce friction. Okay na? In general we provide lubrication to any rotating element, any rotating system to reduce friction. So friction ni tagginchadaniki lubrication use chestam. That is the main purpose of lubrication. Okay na? To reduce friction. So anyhow, here is given some data. So about viscosity given. Viscosity, oil, viscosity of oil. First given viscosity of oil. Viscosity of oil, dynamic viscosity. Mu is equal to 5 poise. 5 poise. So we know that 1 poise is equals to 1 by 10 Newton second per meter square. Newton second per meter square. Viscosity unit, SI unit, Newton second per meter square. 5 by 10 means 0.5 Newton second per meter square. Okay. Next given diameter of the shaft. Diameter of the shaft how much? So diameter of the shaft. Diameter of the shaft, capital D, is equal to. So diameter of the shaft is 0.5 meters. 0.5 meters. 0.5 meters. And it rotates 200 rpm. Speed is equal to. Speed N is equals to 200 rpm. 200 revolutions per minute. It will make 200 revolutions per minute. Calculate the power lost in oil for a sleeve length of. Sleeve length. Sleeve length. So sleeve length L is equal to, capital L is equal to 100 mm. Let us convert it into meters. L is equal to 100 into 1 mm is equal to how many meters? 1 by 1000 meters. 1 by 1000 meters. So L is equal to 100 ones 100 times 0.1 meters. Length of the sleeve is 0.1 meters. Still, any more data? Thickness of oil film, very important. So thickness of oil film. Thickness of oil film is given. Oil film. So thickness of oil film, so denoted by dy is equal to how much? 1.0 mm. 1.0 mm. 1.0 mm. We know that 1 mm is equal to 1 by 1000 meters. So you will get 1 into 10 to the power of minus 3 meters. This is thickness of the oil film. So we have gathered all information. Okay, no? We have gathered all information in the question. So next, at last we have to find power lost. P, capital P. Power lost in the oil. Okay, no? Due to viscosity, there is some power lost in the oil. So viscosity valla emotundi, there will be some power lost in the oil. So we have to find that power lost. Okay, let's solve. So we have to find power lost. Power lost in oil. So power lost in oil denoted by capital P. Okay. So power lost in oil, formula P is equal to, very important, 2 pi Nt by 60. 2 pi Nt by 60 watts. 2 pi Nt by 60 watts. So unit of power, watts. So power lost in oil is equal to 2 pi Nt by 60. So where N is speed. So speed is already given. So 200 rpm. Anyhow, and T is, here capital T is equal to, torque on shaft. Torque on shaft in Newton meters. Here T is torque on shaft in Newton meters. So how do we get torque on shaft? So T is equal to shear force on shaft into radius of the shaft. So torque on shaft, T is equal to shear force on shaft into radius of the shaft. We are going to use all these formulas to find power lost in friction. Next, T is equal to Fs into R. So we already have a diameter, D is equal to 0.5 and radius will be 0.5 by 2. Half of the radius is half of the diameter is radius. Next, here one more unknown is Fs, shear force on shaft. So how do we get shear force on shaft? So here we have in this question he given dynamic viscosity of oil. Okay. So what is the relationship between dynamic viscosity, shear force? Okay. So here Fs is shear force on shaft. So first of all we need shear force on the shaft. Let us find shear force on the shaft. Afterwards we can find torque on the shaft. From torque on the shaft we can find power lost in oil. So how do you get shear force on shaft? So according to Newton's law of viscosity, okay. So we have a relationship between shear stress and velocity gradient and dynamic viscosity. So what is the relation? Tau is equal to mu into du by dy. Tau is equal to mu into du by dy. Here tau is shear stress on shaft. Okay, now shear stress on shaft. So shear stress is equals to shear force by shear area or area under shear. Tau is equal to shear force by shear area. Now transpose AS, then shear force is equal to tau into AS. Here AS means area under shear. Fs is equals to tau into area under shear. What is the formula for area under shear? Area under shear is equal to perimeter of or circumference of cylinder, shaft, nothing but shaft, into length of the sleeve. Perimeter of shaft into length of the sleeve. ఇక్కడ PS అంటే ఏంటి? పెరిమీటర్ ఆఫ్ షాఫ్ట్. సో క్రాస్ సెక్షన్ ఆఫ్ షాఫ్ట్ ఇస్ సర్క్యులర్ క్రాస్ సెక్షన్. షాఫ్ట్ కి ఎలాంటి క్రాస్ సెక్షన్ ఉంటుంది? షాఫ్ట్ కి సిలిండ్రికల్ కదా, సో సర్క్యులర్ క్రాస్ సెక్షన్ ఉంటుంది. పెరిమీటర్ ఆఫ్ సర్కిల్ వాట్? పై డి. సో పెరిమీటర్ ఆఫ్ సర్కిల్ వాట్? పై డి. సో AS is equals to pi d into length of the sleeve L. So Fs is equals to, at final Fs is equals to, what is the formula for shear force on shaft? Fs is equals to tau into pi d into L. What is pi d? Here d means diameter of the shaft. D is diameter of the shaft. Okay. This is perimeter of the circle, actually perimeter of the circle. So perimeter of the circle what? Pi d, 2 pi r. So because shaft cross section is circular cross section and L is length of the sleeve. Okay. No. So anyhow, here we need first of all shear stress on the shaft. So to find shear stress, we have to use Newton's law of viscosity. Okay. So shear force on shaft is tau into pi d into L. Pi d L. So tau is shear force on shaft. Tau is equal to mu into du by dy. Mu into du by dy. So here du means, here du is change in velocity of shaft in meter per second. So here velocity means tangential velocity. So we know that tangential velocity of shaft, u is equal to pi dn by 60. What is the formula? U is equal to pi dn by 60. Now u is equal to pi into diameter of the shaft. How much is given? Diameter of shaft 0.5 meters into speed 200 rpm by 60. Okay. So u is equal to, if you simplify further, you will get 5.236 meters per second. Approximately you will get this much tangential velocity. 5.236 meter per second. Okay. Now du is equal to what? Du is equal to change in velocity means final velocity minus initial velocity. Initial velocity of the shaft is 0 meters per second. Okay, now. So initially shaft is at rest and the final velocity is 5.236 meters per second. So d is equal to how much? 5.236 meters per second. Now we have a du. Next we need dy. Dy anyway given thickness of the oil film. Given 1 into 10 to the power minus 3 meters. Actually given 1 mm. So let us convert it into meters. We are maintaining all units in meters. Okay, meter. Okay. So now let us substitute all the values. Tau is equal to, and at the same time poison's ratio mu is equal to 5 poise means 0.5 Newton second per meter square. Let us plug in all values in this formula, then we can find shear stress on the shaft. Tau is equal to mu 0.5 into du how much? 5.236 by dy 1 into 10 to the power of minus 3. So tau is equal to 0.5. Let us move this 10 to the power of minus 3 from denominator to numerator. You will get negative exponent becomes positive 10 cube into 5.236. So tau is equal to 0.5 into 1000 means 500 into 5.236 into 5.236. Tau is equal to, so anyhow unit of shear stress Newton per meter square. Now we have to calculate 500 into 5.236. So if you calculate, you will get approximately 2618 Newton per meter square. So this is shear stress on shaft. Shear stress on shaft tau is equal to 2618 Newton per meter square. So using this tau value we can find. So okay, here we have tau. We can find shear force on the shaft. So this tau value use cheskoni manam shear force on the shaft find out cheyachu. Shear force. Okay na? Shear force on the shaft. What is the formula? Shear force equal to tau into shear stress on shaft into the area under shear pi d into L, perimeter of shaft into length of the sleeve. Okay. By plugging all these values, we can find Fs, shear force on the shaft. Now shear force on the shaft, Fs is equals to tau into pi d into L. So Fs is equal to tau value 2618 Newton per meter square and pi into diameter of the shaft 0.5 meters into length of the sleeve. How much? 0.1 meters. Actually given length of sleeve 100 mm. 100 mm is equal to 0.1 meters. So Fs is equals to, so if you multiply, you will get approximately 411.23 newtons. So this is shear force on shaft. Using shear force we can find torque on shaft. Okay, now so torque on shaft is equal to shear force on shaft into radius of the shaft. So torque on shaft is equal to shear force on shaft into radius of the shaft. So shear force on shaft 411.23 into radius of the shaft. Radius is half of the diameter. So half of the diameter is radius, d by 2. Diameter by 2 is equal to radius. Okay, now because diameter is equal to 2 times of radius. Diameter is equal to 2 times of radius. Now radius is equal to half of the diameter. Now 411.23 into diameter how much? Diameter how much again? 0.5 meters by 2. If you simplify this, you will get approximately 102.81 torque units Newton meter. Okay, this much torque experienced by the shaft. So next, power lost. At last we can find power lost. Power lost in the oil is equal to 2 pi nt by 60 formula. 2 pi nt by 60. Now power lost is equal to 2 into pi into speed of shaft 200 rpm into torque 102.81 Newton per meter by 60. So 2 ones, 2 30s, 0 0 get cancelled. So power lost is equal to pi into 20 into 102.81 by 3. So at last power loss is equal to, now calculate this value using scientific calculator. You will get approximately, here I got 2153.25 watts. 2153.25 watts. This much power lost in oil due to viscosity. So power loss in kilowatts 2.153 kilowatts. 2.153 kilowatts. Okay.